So, start the change here. Hopefully you all saw lessons last night. A little out of it still. I think we'll be okay. It's not too bad here on my method. So, um, we'll see. So it should be a little better today than yesterday. I slept like awful yesterday. I got up at a real fevery. Thought that'd be a bad idea to share all those. Appreciate you being here online with me. Oh, there we go. Look at that. Music. Stop that track. Cool. So we're going to pick it back up here. Let me go pull up our module here. Got some arrays and vectors on tap today. Now, some of it will be some review. I don't know exactly how far you got into arrays and vectors last semester. So if it's too slow, let me know, but I'm hoping to speed through most of this here. And then we'll get into some interesting, hopefully interesting stuff with two-dimensional vectors and dealing with those and then doing some exercises with those. That sound like a plan? So let me start up Visual Studio here, Visual Studio, and we can start up a new project. We'll grab a C++ project. All right, and let's call this one, what do we want to call this one? This will be week 4, arrays and vectors. That sound right? Yeah, this is week 4, arrays and vectors. There we go. So make that project, and then I can check my GitHub client, make sure it's, I don't want to do the survey right now, no thanks. Make sure it's all going to show here. Come on, repository dropdown. Thinking real hard about it. Come on, there we go, 200 fall. All right, cool, so we got our solution file, PCX project file, filters file. Life is good. We can see this, so we can add our source file. Source CPP, sure, why not? All right, and then we can do our usual thing. So we want to use our namespace. We want to include our IO stream, and we can have an int for main. Okay, all right, just our usual starter stuff here. So I want to pick up a little bit more where we left off with the dynamic arrays. Spend a little bit of time looking at that, some other interesting things here. So right, if I just wanted an array of integers, we'll call these ones my values. Right, equal to new int array, and then let's say this is maybe size 10, or how about we even ask the user how large they want here, because this is where it starts to get fun. So we can have an int, so we can see out, how many numbers do you want to store, and then we can see in an int for, I don't know, number of values, and we can see in number of values, and then we can make this size of number of values. And this is where we weren't able to do this with a regular array, right? I think we looked at that. If you just wanted to have a regular integer array of numbers, we said in size, number of values, and this was numbers or something, it starts to get upset with us. Oh my goodness, I think I'm backwards here. And now, because this is not constant, it's not constant at compile time, so it's upset with us. We can't make a regular array because we don't have a constant value for compile time, but we can with dynamic arrays, with our allocating memory in the heap, which is great. So I can figure out how many I want, and then we can loop through. I can say for index is 0, index is less than my number of values, index plus plus, and we can go and give these some values here. For now, let's just say values at the index equals the index. We'll just get 0 through whatever that number is here. Right, and we can go see what those are. So this is nothing super new, but now one of the, I say it's kind of silly, but one of the silly things you can do is you can use a pointer to loop through. You don't have to use the index if you don't want to. Now, I don't know why you might want to do this, but you'll see people do this sometimes. So we can say for int I don't know, let's just do index again as 0. Index is less than number of values, index plus plus. And then what we want to do is we want to keep a pointer to the current value. So I want an int pointer called the current value, and we're going to start it at the start here, so values, right? And we're going to loop through. So I can actually see out here, if I just want to look at the first one, I can see out current values, current value. Now, I'll leave this loop for now. When I go to see out the current value, because it's a pointer, I'm going to get the memory address, because that's its value. So if I want to dereference that pointer and get the value stored at where it's pointing, I can dereference it here. Right, so this should give me the first value. It should be 0. Nothing super interesting. We'll say 10 numbers, and the first value there was 0. Great. So what I can do is I can put this inside my loop. Cat, that hurts. Sorry, my kitten wants to play. So if I put this inside the loop here, then what I can do is I can take current value and I can say plus plus. What that does is, because C++ knows that an integer takes up 4 bytes here. When I say int pointer plus plus, it's going to move this 4 bytes. So when I move it, then it's going to look 4 more bytes in memory, and I'll see the next value. So I can loop using a pointer and get out these values here from 0 to 9, right? Up to but not including 10. And what's kind of fun, so we can add in here, so we could say something like at memory address, and then we could actually add the current value, and then we could add, like, here's the value that it stores, and then dereference the pointer. That's a little long. I'm zoomed in a lot here on the screen. Sorry, it looks a little long. It's not too bad. And then we can increase current value. So we can look in and see at these memory addresses here, right? So it's moving 4 at a time, right? This is hexadecimal notation. Doesn't have to make a whole lot of sense. That's okay, but it's base 16. You'll get more into that in some other classes. We can see what the values are. So we'll see the pointer is just moving 4 bytes at a time. Now, what's dangerous here is you can do some dumb things. So I could say, hey, let's do this to less than 15, because maybe I was forgetting that I was going to ask the user what size here. So if I only store 10 values, I'm going to get, well, here's the next memory address, here's the next memory address, here's the next memory address. What do I get here? I have no idea, but if we were to look at what's in memory, this is the integer representation of what those bytes are. I've got no clue, right? This is not memory we should be touching here. So you have to be careful that you don't do some bad things here. And this is why so we usually like to say C++ is a little dangerous, because nothing stopped me from doing that. And if I try and use some of these values in arithmetic, I'm going to get some really weird results. Right? This is not what we want to have. This is no good here. Okay. So that's using the pointer, they call it like pointer arithmetic. So it's jumping around, and we're just going one at a time here. But that is how you would go and get values out of these arrays or out of these vectors in what's known as constant time, where you just know where you need to go look this up in memory. I don't have to read the first value and then go to the next one and go to the next one and go to the next one and go to the next one. I can just jump to any one of these indexes here and get the value at that index. And that's what's happening behind the scenes here. When you say values at index, it's taking the memory address of values and adding the size of whatever type it is here, so 4 bytes, times the size of the index. Right? And that way you can just jump around and go find those things. So we can do the same idea with our own pointer if we want. Okay, and that's the whole idea with those here. Hey, thanks so much for following along. Glad to have you here. I'm definitely going to need some more coffee because, well, this is kicking my butt. All right, so that is looking at that, a pointer arithmetic using pointers here. Now, if we want to do the similar idea with vectors, we can include vector. And I'm a big fan of vectors. I think vectors are so much easier, so much nicer than our static arrays, and they just work. So we can do similar things, like here's a vector of type integer here. We'll just say, what do we want to call this one? How about numbers? And what size do we want it to be? Well, let's size it to, let's ask the user the number of values, right? Whatever they told us, we'll put in here. And then with vectors, you can even give it a default value if you want. And say, let's start them all at 0. You don't have to, but it's nice to give them default values, because otherwise you've got garbage here. And then with a vector, when you loop, I'll say for index 0. Now, some people like I hate I, because I get really confused when I see I's, because they look like other letters sometimes. So I prefer the word index. You're going to see me write out index all the time. And really, it doesn't take any more typing to write index, right? If the 2 extra letters you have to type and then hit tab to autocomplete bother you, you're doing something wrong here. So let's say index is less than. Now, anytime you're dealing with a vector, you don't want to use a fixed value here. You want to ask the vector what size it is. So the vector variable dot size will give me the size of that vector. So this is always preferred when you're looping through a vector to make sure you're going from the beginning to the end here. And we can add one to index. So what we want to do then, if we just want to go set all these values. Now I know we started them all at 0, but that's fine. We can take our numbers. We can say at the index is equal to the index. We'll go set the location at the index to that index. And again, we get the same thing like we did here, where you go and set their values here. We're just going to go set them in the vector. And then if we just want to see out hello world, I just want to be able to put a breakpoint in here. So I need something here. With a vector now in debug mode, we can actually see the values of the vector, which is fantastic. So I can open up my numbers vector. It says, hey, it knows it's size 10 here, and I can see the value at each of those indexes. So vectors are way easier to debug as well. I don't have this just values list where I only get to see the first value because it's a pointer, right? It's hard to see what that is here. It doesn't work very well. And the other nice thing that you get is when we want to loop through, so for index 0, index is less than, and let's say we did the same mistake. If we said, hey, 15 instead of size here. If I wanted to see out the numbers dot at the index here, and line, you'll notice we get a good helpful thing. Oh, we're going to take out that breakpoint, sorry. Where'd it go? Did it stop? Where'd it go? There it is, 10. And we get an exception unhandled, an out of range exception. Now, you might think this is bad that it crashes, but this is good. We want this to happen. You don't want your program to access a value that is out of range, where that index is invalid here. This is fantastic. We want that to crash. Come on, come on. Keep going, keep going. Oh, because we did like 15 of them here, right? We wanted that to crash. So let me just go and instead of start without debugging here. So we say 10, and we get, hey, here's our error here. We can abort, we can retry, we can ignore. Notice the exit code's not 0 as well because we had bad stuff happened. So our program crashed, which in this case is a good thing. We wanted it to crash because we did a bad thing. That's something we shouldn't have been allowed to do. So vectors are nice because they protect against that here. Right? So vectors will throw an exception, access an invalid index. And again, that's useful. We want that to happen. So you shouldn't be accessing those indexes, right? That's the problem. The other really cool thing, so actually I'm going to leave that commented out here. Isn't it control? No. Edit. Advanced. I want a comment. Toggle line comment. Control slash. Oh, that's what I pushed. No? Oh, control K plus control slash. That's right. It's both letters. Okay. To comment it out. So I don't want it to crash on me here. The other really cool thing we can do with vectors is I can use pushback. Right? And the idea with pushback is it's going to add to it, where with an array, we were fixed in size. We had no way of increasing our size or decreasing our size. We were stuck. Where if I push back, it just goes and adds to it, which is really nice. So let's go add, let's say 42 to the end here. And then let's loop through and look at the values again. So we'll get the first, let's just store 5 of them, right? Nope. What did it do? Oh, I got rid of my C outing. That's what it was here. This is setting. My mistake. I wanted this line. That was a bad copy paste. There we go. Now we'll run it. Now we'll see that last value should be 42. Right, we get the first 5, and then we get 42 because we just pushed it onto the end. It was added right to the end. Worked out really nice. Okay, so this hopefully was a lot of review of vectors. Nothing super new and interesting yet here. Right? Always using size. Then we can push back. You can resize them if you want to make them smaller. You can do all sorts of fun stuff here. Make sense so far? Feel free to chat at me here. No, I don't have the voice chat or anything on right now, but I think we got a couple people found it. Yep, awesome. I'm looking at my other screen. You guys can't see that screen on my share right now. I should know that. Told you I'm a little bit out of it with all the meds, but I'm feeling better, which is good. It is nice to feel a little better. Okay, cool. So nothing too crazy. So now let's look at a two-dimensional vector. So where you have a vector of vectors. That's where it starts to get interesting here. So let's make a vector of type integer. And this will be, let's just call it a grid maybe. Now, what size is this? Well, this will be the number of rows that we have. So I'd like to think of two-dimensional things as rows and columns. And here, actually, I've got my cool tablet. I meant to bring this. I'll probably bring it in Wednesday when I come, because I really should bring it with me, because this thing is awesome. So I can draw on the screen here. Now, probably the easiest thing for me to draw on is actually Word, which is a little sad, but that's okay. So let's go to draw here and then do something. So with this, so what we get here, right, we get this idea that here, that's the eraser. Here's the first vector or array, right? And inside of this, then we're going to put in another vector. So how many of these do we have in here? And really, we can put as many as we want, but trying to look at all in one big row format is a little bit ugly here. So what we usually like to do is we sort of imagine this as stacked. So we'll say, hey, each row then, right, is a vector. And then each one of these can have its own, let's say like 1, 2, 3, 4, 5 slots. And then we have another row, 1, 2, 3, 4, 5 slots in that vector. Then we have another vector, 1, 2, 3, 4, 5 slots or so. Right, are these two-dimensional vectors new, or did you guys talk about these in 150? Because hopefully we're not going to waste a lot of time doing too much review, but this will be interesting later, I promise. Me Marchy, 3D vectors, my friend, you are very familiar with how much I dislike 3D vectors. If you have to have rows and columns and then like depth, it starts to hurt my head. I'll be honest, I'm not the smartest or the sharpest tool in the shed. Is that what we say? And I have a really hard time conceptualizing anything more than two-dimensional vectors. So I mean, 2D is it's not too bad, and they do have a relatively common use case for two-dimensional vectors. And rows and columns, I think, is generally easy to understand here, but 3 dimensions starts to be really complex, and just trying to understand all that can get a little tricky here. So what we have in here now is we have rows and we have columns. So row index 1 or 0, 1, 2, 3, and 4. Right, so these are the row indexes. Right, and then up here we have the column index, 0, 1, 2, 3, and 4. These are our column index. So to reference any particular item on this grid, you first tell me what row it's in, and then you tell me what column it's in. So I could say, hey, I want position 3, 3. There's row 3, column 3 right here. We could put something, right? Or maybe you want row 1, column 2. We can put something over here. And this board's a little large for tic-tac-toe, but we can, do all sorts of fun things with it as we go. So with a two-dimensional vector, we think of rows and columns is usually the easier way of thinking about it. And it you can visualize it a little bit nicely that way, if that makes sense. So to put that into code then, right, we're going to have a bunch of rows. Let's say we had 5 rows. And then for And now I like to say row index starts at 0. Row index is less than, sorry, had all this drainage here, is less than, now I could do my grid.size, or I could just do 5 because I know it's 5, or we could have some sort of value here. We got lots of options here. Row index. Index, there we go, if I could spell that right. Less than grid size, row index, plus. What we want to do then, I want to take my grid, and I want to be at the index, right, is equal to a vector of type integer. At row index, there we go. Now what size though? What size do we want this to be? So really maybe we should say, we'll call this the row. And these are size 5, right? And then we can take my grid at the index, row index is equal to the row here. We can put in 5 rows then. Now we probably want to give these some value, so I'll do 0 to start for right now. We can figure this part out after. And then we can see what we have. So if I just see out hello world, again, something. So if I put this in debug mode and I look at it, or actually we could probably debug mode right in here. This might be fun to watch it grow as we go. I'm sure store some numbers. So now I have my grid here. It has 5 empty vectors here right now. Their sizes are all 0 to start. So we're going to start adding to them here. So we've created this row vector of size 5. And then when we step now, my grid here, now the first row has 5 values in it. So you can actually see the first row and then all the values inside of it, which is nice. Then we can watch as we go. We'll keep adding more and more of these. Keep going. So now my grid has a couple size 5. We'll keep adding some more. It's done. So now I have 5 rows of 5 columns each here inside my vector. Okay. All right. Awesome. So we might actually want it to be a 5 by 5 grid exactly. We might want to make this a little bit a little cleaner, or not cleaner, be sized a little differently here. So let me go and Google here. So the game Connect 4, right, has this grid of, what is it, 1, 2, 3, 6, 7 columns and 6 rows. So I'm going to have 6 rows with, I'm sorry, 6 rows with 7 columns each. So I want to have 6 rows, and each of those should have 7 columns each here. And then really integer is not exactly what I want to use here. So I want to use, how about a char here? Make these vectors of chars, and then the character I want to have is a space character to start. That's an empty location here now, right? And that should be fine. So now we can have a 6 row by 7 column grid that we're going to print out here for our board. This is our little Connect 4 board, okay? Excuse me. And now putting it just in here, we can add other functions and all sorts of other things, but hopefully you're thinking, hey, if we're going to build out some sort of game and have some sort of logic and have ways to interact with it, we can make a class. And yeah, we sure can. So let's add a class here. This will be our Connect 4 header file. We'll have a class for Connect 4. Right? So Connect 4 will have a private section, and it'll have a public section. So in the private section, we want to, we got to add all of our other nonsense here. Let's just go copy paste. Now I don't actually need the IO stream here. I shouldn't need it. Maybe we do. I'll leave it in. We'll add one way to interact with it here in a second. So Connect 4 should have a private character for the current player. So we'll know who the current player is, right? And we'll have a vector of vectors of characters for the board here, right? And then what else does a Connect 4 game need to know? That's probably about all that it needs to know, right? And then ways that we might interact with the Connect 4 board, right? Well, we're going to need a Connect 4 constructor. Probably doesn't need to know any arguments here. So what we need to do is we need to create that board. So I'm going to take all of this nonsense over here, and we're going to move it into our constructor. So this was our board here, though, right? Board. Okay. So we can initialize this, and then we'll set current player to X. Or I'm sorry, what do we have? Like it's like blue and red or something like that, or red and yellow, or we could have X's and O's. It doesn't really matter here. That's fine. So we'll just have X or O. Okay. With me so far? So we have a Connect 4 board, or the game essentially. It's going to track whose turn it is and the board. And then we can have ways of interacting with this game here. So I'm going to have a, how about have this be a type of Boolean here for drop piece, given the int of the row number, or sorry, the column number. Okay, so to drop a piece in, when you play Connect 4, right, you put it at the top and it will drop down to the lowest possible row, right, of that given column, right? So we need to find that column and see if it's empty. Okay, so what I want to do, I want to just start, yeah, pretty much they're like array lists in Java. Yep, yeah. So if I want to drop a piece, I want to start at the bottom here. I want to start at row 6 and say, are you empty? If it's empty, the piece goes here. If it's not empty, let's look at row 5. If it's empty, piece goes here. If it's not empty, go to the next one. If it's not empty, go to the next one here. So we're going to go backwards here. So I'm going to say for int, this is my row index, is going to start at my board.size. And I'm going to take, as long as row index is greater than or equal to 0, we're going to take row index minus minus. Okay, so we're going to go from the size, and actually we want that to be size minus 1, sorry, because there is no index at size. Right, so if it's size 6, the last index I have is 5. Right, so start at 5, going up through 0. We can say, hey, if my board dot at the row index dot at the column index that you told me, or column number, how about column index? I like column index. I like that better. If that equals an empty character, great, I can drop the piece. Excuse me. Oh man, I got some real bad drainage here. Okay. Oh, sorry about that. All right, so if it's empty, great, now we can say the board at the row index, at the column index, is equal to the, the current player, right? Then we need to change current player. So there's a couple ways of doing this here. I'm generally not fond of this ternary operator, but I think it's cute in this place here. We can say current player is equal to here. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. You, my friend, are helping fund our scholarship. That is awesome here. I appreciate you being here on Twitch with us. So we need to change current player. Now we could say, okay, we could say if current player is equal to, is it capital X? Yeah, capital X, right? Then current player will be equal to, how about, we'll do X's and O's. Otherwise, current player is equal to capital X, right? If it is X, turn it to O, otherwise it becomes X. And this is fine, no problems with this here, but that ternary operator is kind of cute here. We can say current player equals here, and then we can check current player is equal to an X, colon, then we get an O, question mark, otherwise we get a X. Is that backwards? It's backwards. I can never remember the syntax. This is probably why I hate them here. Right? Does this ring any bells, this ternary operator? Give you the expression, if it's true, you get this. If it's false, you get that. I think that you might have looked at it once here. It's just cute is all. So and you know, and as a single line, I like that here, I guess, rather than 6 lines of if else, but not too big of a deal. Stella, sweetie, it's really hard to type with you in my lap. Stella wants to say hi. She is, how old are you, baby? She's born on April Fool's Day, we think. So that puts her at 5.5 months old. She's still quite the kitten. All right, anyway, so if that all works, then we can return true, you dropped a piece. If we go, oh my goodness, cat, she stepped on my trackpad. If we go through, no, not this screen, you go up here, there. If we go through that whole loop and we haven't returned to true, we can return false because that column must be full, right? If I can't drop a piece, put a piece in, then the column must be full. Stella, baby, okay, you know what, you can stay there, go for it. Just stay off the keyboard. Okay, so I can drop a piece in my board here, right? And then other ways we might want to interact with our connect for, we should probably figure out whose turn it is, right? So we can have a char for get current player. We can return current player, so we know whose turn it is, right? And now we could return this board vector if we wanted to give someone access to it, but generally that's a little risky because like they could go change it or play with it or modify it or do something here. So we can make a copy of it. We could do that, right? If we return a copy of that here, we could do that. So we can have a vector of type vector of type char here for, I don't know, get board. And then we want a vector of type char board copy equals the board. Right, so we get a copy of it here, that copy assignment operator, and we can return the board copy. Stella, you have to stay off the keyboards. All right, I might have to take her upstairs here. She's having all sorts of fun. Okay, so if we make a copy of it here, we're in better shape with it. You know, do we have to do that? We might have to do that on 2 lines here. Board copy equals the board. I forget. I know the copy assignment copy assignment operator is set up with vector, and that does work here. I don't remember if it works on that first line. Can we do board? No, we can do. Maybe we can do that. The copy constructor, maybe. I think the copy constructor works. And we'll return a copy of it here. And then the other important thing here that our game should know if the game is over or not. Right, so we can have a Boolean for is game over. Now, is game over is a bit of work here, right? Because we have to look for connect fors. Maybe you're on top of my tablet. Stop. She's climbing on the tablet. All right. She's not used to me being here this semester. This is a little different now. All right, we'll just put that over there. So this one is a little tricky, right? Because you can have 4 in a row straight up and down. You can have 4 in a row horizontally, and you can have 4 in a row diagonally up or diagonally down. Right? A couple different ways to look at this here. So what I'm a big fan of is this idea of functional decomposition, right? We want to break this down into smaller and smaller problems so we can return the, excuse me, or there's also the game is over if every single piece is full here. So we'll break it down into all those steps. So we can return has winner vertically or has winner horizontally, or has winner diagonally, or board is full. Right? Any one of those then being true means the game is over. Now, sure, I don't have any of these, so we need to go and make these methods here. Now, these don't need to be public methods. Right? These can be private methods, so I'm going to add them to my private section here for a Boolean is, or what do we have for all these? Has winner vertically, right? And then for now, I'm just going to put in false because we'll get to this here. Sorry, we should return false. Return false. And a bool for has winner horizontally, will return false. And a has winner diagonally. You can return false. And board is full here. Return false. Okay, and now we can go and solve these one at a time as we try it here. And we can figure out how to go and solve these individually as we go, right? Vertically is probably the easiest. I don't know. Vertically and horizontally are probably the easiest. Diagonally is a little trickier, and board is full is pretty easy. But we can get to it here, okay? Now, if we wanted, we could give someone a way to print the board that generally kind of goes against our class design. Right? The idea with a class is that it is fully independent here. It just stands alone, has its own features and functionality here. Stella, stay back there. And it shouldn't know that we need to do this input and output stuff here. So I'm going to get rid of the IO stream. It shouldn't need IO stream for anything. My class should not deal with the user at all. The part of my code that deals with the user is, if I'm starting in main here, my main method can do that. It can deal with the user. But Stella, my goodness. So I don't need to do any of that because ideally this class is so good and so fantastic. Maybe I want to use it not just in a console-based application where you have to type in the console, but maybe I could use it in a graphical user interface application. Maybe I could use it in a web application. Maybe I could use it in a mobile application. Right? The class should not be tied to one of those particular implementations here. The class is just the logic. Right? We're encapsulating all these details, making a nice, neat little package here, and storing it here where I can get at it any way that I want to in some other way of talking with the user. Or maybe I even want to make the computer play itself. Right? Maybe we could put this into some sort of machine learning model and find, yes, Connect 4 is a solved game. The player who starts can be guaranteed to win. I don't actually remember how that all works. At one point, I tried figuring all that out and memorizing it here, and then I got tired. But it is possible for the first player to start to always win, right? To make it impossible for the player to win the game, which is a little sad here, but it would be kind of fun if we went and figured that out. That's a problem for another time here. But for now, our is game over, and we should be able to interact with this here and figure it out. So in our source here, then we can make a new Connect 4. We'll go include Connect 4. Right, we can make our game here, so we can have, we don't need to see out Connect 4 game, and we can say while game dot is game over, and really want this to be not is game over, right? We can see out game dot get current player turn and line, and then see out enter the column index, and you want to drop a piece in, right? And this we didn't do a very good job here and drop a piece because we should have validated here first, right? We should make sure that if my column index is greater than or equal to 0 and column index is less than or equal to, now I can't just get the board size here because that's going to be the number of rows. So I want the board dot at 0 dot size, right? That'll be the size of the row, not the number of rows, right? Because the size of the board is the number of rows, not the number of columns here. So if all of that, then we're just going to return false. Right? You are no good here. Go away. You give me an invalid number. Okay. Otherwise, then we can go and check it here. So this is going to be protecting our integrity. Now, again, I'm just using a Boolean. I'm not throwing an exception. We could throw an exception, perhaps, but I think this is going to be okay for now. I mean, we could go either way with it here. If you like exceptions, go for it. But just communicating false is probably fine because nothing else changes. If I return false and they ignore it, well, we haven't changed current player's turn. So it really doesn't matter. They can try again, but it's going to be the same player's turn. Okay, so we'll get that, and then we'll try. So then we need an int for column index, and then we can see in the column index, and then we can try game.drop piece at the column index. Column index, there we go. Now we want to be able to print the board here. So I didn't give a way to print the board here in game, in the Connect 4 game, because we don't know how it's going to be used, right? So after we drop the piece, we probably actually want to print the board first here. So how about we say for int row index is 0, row index is less than my game.getBoard.size, row index plus plus. Now, getting the board out over and over and over is going to be a little bit silly here. So let me actually get the board here. So we'll do a vector of type char, call it the board is game.getBoard, because otherwise every time I call getBoard, it's going to go make another copy. We probably don't want that here, right? So now I want to print all these out here. So for the first row, right, I want to print out board. So I want to say for int column index is 0, column index is less than my board dot at 0 dot size, right? The number of columns that I have here, column index plus plus. Right, so now we want to see out my board dot at the row index. Actually, I guess we could do row index here too. It doesn't have to be 0. It's fine. Dot at the column index. And I want to add a space, right? Just to kind of space separate those. After I've done printing all of those, right? Then at the end of that, I want to see out an end line here. So I go down a line. Then the next row. And I'll print the next row, see out, do that, do that, do that. Now, this is going to be a little bit squished in here. It might look a little funny here. So we might want to try and make this look a little nicer here. So maybe I will see out a pipe character here between each of these. Instead of being space separated, we'll put a bunch of pipes here, and then I'll do another pipe at the end, and then an end line. And really, we want this to be, to have like, if this were to look like a grid here. So I'd want to be able to print out some dashes across to kind of box all of these in here. So if we want the box there, I can see out probably a bunch of dashes here. I don't know exactly how many dashes it's going to take, right? So it's the pipe 0, another pipe 1, pipe 2, pipe 3, pipe 4, pipe 5, pipe 6, pipe, something like that. It's probably pretty close. Then we can end that row, and then the next row we'll print all these, and then when we're done with all of that, we'll see out one more time for the bottom, and we'll see if that gets close here. It doesn't need to be necessarily exact, but we'll see if we get close here. We'll drop a piece. And we should just be able to keep on going here. So let's run that in debug mode and see if we get some little output here. So 10 numbers, sure. All right, oops. So we only got that. We never got the rest of the board. What happened to our board? So something happened with our get board here. Let's see, what happened to our board? Oh, that's what happened. I made another board here. So in the constructor here, we have changed this board. We're not using that board here. Oops. So we don't want going off of board size. That's unfortunate here. So we'll just say then this should be 6 rows here. And then I will push back my row. So we'll just add that in. There we go. So before I wasn't using the class level board variable here, right? We've created a new variable called board that was local just to this constructor, scoped just to this constructor. So now we've got a board, we can go and push it back here for every row that we want. That should be a little nicer. Again, we could probably say 6 up here if we wanted and do that size thing, but this is probably fine too, to do all that pushback here. Okay, so let's give that a run now and see if this looks any better for us. 10 numbers again, sure. Okay, cool. Hey, look at that. Now we have a nice little Connect 4 board here. Right, what column index do we want to drop a piece in? So let's start somewhere in the middle here. So how about 3? Uh-oh. It didn't do it. Still X's turn. Okay, well, let's put it in debug mode. Let's go back to our Connect 4. Let's try and drop a piece. Let's come over here maybe. Let's try it again. So we had that drop piece. Where'd that go here? Oh my goodness, this one over here. Yeah, that one. So we'll try 3. It's not even debugging. All right. Let's see. Oh, yeah, I'm returning false way too soon here. This is backwards. This is not what I wanted. This is the valid, not the invalid. So I want if we're less than 0 or we are greater than or equal to the board size, we can return false. There we go. So we were returning false way too soon. So if it's invalid, return false. Okay, so let's try column 3. Okay, there's our debug. We're in here. I'll just continue on. I think that'll work well for us here. There we go. So we get an X at column 3. Now it's O's turn. So where does O want to go? This is where you get to join us, chat. We got to try and play Connect 4 here, although it's never going to finish because we never finish the rest of our code. But we just want to see if we can stack a couple of these numbers here, right? So 2 and 4 and 1 and 3 again, and how about 2 again, and then we go to 2 again for X, and we can see we start building out the board as we go, which is kind of fun. So we'll just kill that. Yeah, breakpoint, that's fine. Okay, so now we need to finish the rest of our helper functions here. So how do we know if we have a winner? All right, so let's check, let's do vertically first. Okay, so to check vertically, we need to check every column index. So I'm going to say for int column index starts at 0 and column index is less than, now we'll do board dot at 0 dot size here, column index plus plus. So looking at every column then from 0, 1, 2, 3, 4, 5, 6, right? Because we have 7 total columns in our game here, 6 by 7. We're going to look at each one. Now, if I only have 6 positions here, I didn't draw that out very well here. We didn't finish that, but we can do a little bit, make our math a little easier here, because if I only have 6 rows here and I need to have 4 of them done, I know the middle 2 have to match, right? It's sure, and then either I can go up or down from there, but it's okay. We if we're going to start at 0 and look for 4 in a row, great, we can do that, and then we can look at start at 1, look for 4 in a row. We can start at 2, look for 4 in a row, and then that's it, because we only have 6. So there's only 3 starting positions, 0, 1, and 2, that we need to look at. So I'm going to do another loop here then, and I can say for int, this is row index. No, stay off the keyboard, Stella. Row index is 0. Row index is less than, now less than or equal to 2 maybe, because I have 0, 1, and 2 are the possible starting locations. I could do that, or I could say less than 3. Really just a preference here at this point, doesn't matter too much. Row index plus plus. Great. So now starting here, I can see if I have a match. So I want to say if my board dot at the row index dot at the column index, oops, column index, come on, type ahead, does not equal a space, right? That's the good starting point here, right? So if we're not a space, we might match. Stella, come on. Stop. She keeps getting behind my computer here. All right, you're gonna knock over my coffee. So it's not a space, and then they all have to match. So if they all match here, so we'll say, hey, this one is equal to this row plus 1. Right? So if my row column matches row plus 1 column, and hang on, I'm going to go down a line. This is getting a little long here. I'm sorry, but I wanted to. Those all probably should be on one line here, because otherwise it's just silly. Here, so row plus 1, row plus 2, row plus 3, and row plus 4. Right? If they all match. So if the first one matches the second one, the first one matches the third one. Oops, we don't need that last one. My bad. Here, that's too many. Right? So if the first matches the second, the first matches the third, and the first matches the fourth, and they're not empty, then I know I've got a winner. So I'll look at all of that here. Where's that parenthesis here? Where's my matching parenthesis? I need, oh, okay, that one does match there. There we go. So the curly braces. So if they match, I can return true. I have a winner. And I do that for every row index. So starting at row index 0, I'll check 0, 1, 2, and 3. And then starting at 1, I'll check 1, 2, 3, 4. And starting at 2, 2, 3, 4, 5. And I'll do that for every column. Right? Then I found a winner. If I haven't returned true by the time I'm done with all of that, I'm going to return false. I don't have a winner. Okay, so that's how I can check a winner vertically. Let's try it. Let's see if we can win vertically here. So let's just do 1 and 2, 1 and 2, 1 and 2, 1 and 2, 1, and the game's over. Right, the loop stopped. Stella. Right. Okay, so it didn't print out that last one. That's kind of a bummer. So we might want it to print. Maybe we have it print after. Should it print beforehand or after? Like, I guess it's nice to see the board. So I don't know if I'm going to print more than once here. Let's take all of this here, and I want to extract this as a function here. This will be print board here. Given a reference? No, I don't know. I'm not sure. We can give it the game. Why not? Okay. So now I have a print board function given a connect4game reference. Sure. And then I can call those methods on that reference. Why not? So when the game's over, then we can print the board one last time, save us one little bit of typing here. Okay. Sure. So 10, we'll do 1 and 2, 1 and 2. Oops, 12 was no good here. 1 and 2, 1 and 2, 1. Game's over. I see my 4 in a row. Awesome. So that worked vertically. So we're going to go back and do the horizontal. So horizontally now we need to check every row again. So for row index or int row index starts at 0. Row index is less than. Now when we're looking at rows here, remember I have 7 positions. So I can't get 4 in a row past starting at 3 because I can have 3, 4, 5, 6. That's the last one. So less than or equal to 3. Same idea that we did with the other one, row index plus plus. I'm going to look at every row here. Then, nope. I'm sorry. This is no. We want to look at every row. Then the columns. There we go. Sorry. So this is board.size. Now for int column index. There we go. Column index is 0. Column index is less than. There we go. Less than or equal to 3. Because there we go. So looking at column 0, column 1, column 2, and column 3 for every row here. There we go. Column index plus plus. We're pretty much going to steal this here. It's going to be a little different now, though. So if it's not empty, and then instead of changing rows here, I want to change columns. So column plus 1, oops, plus 1, column plus 2, and column plus 3. And it's going to want to space all those out because that's my nice little formatting here, right? Okay, so if they match here and then move to the next column, that matches, move to the next column, that matches, move to the next column, that matches, great, we have a winner. If we've done all of that, we haven't found a winner, we're going to turn false. No good here. Okay, and let's see if that works for us now. Okay, so let's try, oops, oh dear, out of range. Where was that? Is game over, has winner horizontally, row index was 6, column index was 0. Oh, I have my less than or equal to. That needs to be less than board size. There we go. There we go. All right, let's give it a shot. So let's try a horizontal win. So I'll do, we got to stack all these numbers up on top of each other here as we go. So let's do 0 and 1. Oops, that was not right. So I want 1 and 2. I want 2 and 3. I want 3 and 4. And look, we've got a winner horizontally here for those. And it stopped. It's fantastic. Excuse me. So we did the easy ones. Vertically and horizontally are the easy ones. Okay. Excuse me. The diagonal is a little harder here. And I'm actually going to break this one up into 2 here because I'm going to say has winner diagonally up, turn false, just to have something in here, and a Boolean has winner diagonally down. Right? This idea that you can go upwards or you can go downwards. Either one here. Return false. So I just want this then, so winner will be has winner diagonally down or has winner diagonally up. Right? Either one of those here will work for us. But again, we're just going to break those problems down into smaller and smaller problems. So let's do the diagonally down first. So if we're thinking about diagonally down, right, I need to get a 4 in a row going down here. So similar to these cases here, I can't start at past column 3 and I can't start at past row 2 because I'm going to be increasing my row number each time and I'm going to be increasing my column number each time here as we go. 'Excuse me. So we're going to do the same kind of loop here. So for diagonally down, I'm going to say has winner diagonally up. So has winner diagonally up. So I'm going to say has winner diagonally down or has winner diagonally up. Either one of those here will work for us. But again, we're just going to break those problems down into smaller and smaller problems. So let's do the diagonally down first. So if we're thinking about diagonally down, right, I need to get a 4 in a row going down here. So similar to these cases here, I can't start at past column 3 and I can't start at past row 2 because I'm going to be increasing my row number each time and I'm going to be increasing my column number each time here as we go. 'Excuse me. So we're going to do the same kind of loop here. So for diagonally down, to say for int row index is 0, row index is less than or equal to. Now we need to start at 2 or less, because I only have 6 rows. So I'm going to stop at 5. So I can have 2, 3, 4, 5 is the last possible row I need to look at. Row index plus plus. And then for each of these, a similar column index idea here. Let me just steal this line here. Right? If we're going to go across columns as well, we can get to no further than 3. So I only have those couple starting positions here that I need to be starting to look at. And then the math, or the check here, is the same check, right? Now what changes though is, okay, it's not blank, and then each one of these is going to move. So it matches row plus 1 and column plus 1, or matches row column plus 2 and column plus 2, or matches column plus 3, row plus 3. Right? Because we're going downward, so we're increasing our column count, and we're going across by columns, so we're increasing the column count. They match, so we can return. Am I missing a curly brace? Oh goodness. Here's my if. There we go. If we've done all of that, we can return false. We haven't found a winner. Okay. Diagonally up is the same thing here, but we're going to go in a different direction. So to go diagonally up, I want to start at the bottom, and I want to decrease my row count. So I'm going to start at the board.size minus 1. And then as long as we are greater than or equal to, now I'm going to be at 5, 4, and 3, because I can be at 3, 2, 1, 0. If I'm going upwards is okay. And we'll take my row minus minus. So now instead of looking at row plus 1, it's row minus 1 to go up a row. Row minus 1, row minus 2, row minus 3. So when I stop at 3, I'm going to get 3 matches 2, 3 matches 1, 3 matches 0. But again, columns are still going up, because we just need to check that direction here. Okay, so we have both of our horizontally winners, and then if we're full, this one's actually pretty easy here. So we're going to say for int row index is equal to 0, row index is less than my board.size, row index plus plus, and then we're going to look at every single column here as well. So for column index equals 0, column index is less than my board.at the row index dot size, column index plus plus. And if my board.at the row index dot at the column index is equal to a space, oops, missing that parenthesis here. If that's a space here, I'm going to return false. If I find a space, we're not full. If I don't find a space, we must be full. We can return true. Okay, let's give it a shot. So, and let's see. So let's try a diagonal win first. So we'll go 0 and 1 and 1, 2 and 2. We need 3 and 2. Okay, so we're getting diagonal here. So then I need 3, 3, and then let's just go back to like 0, and then 3 again for x. We get a diagonal up win. Stopped. Okay, looking good so far. Let's try a diagonal down win. We want to test this stuff out here. Now, again, we're doing the poor man's testing. We're not really doing any integration or unit testing, which would be nice. And that's actually way easier than doing it this way. I'll show you in a minute here how we can do our testing here as well. So let's stack this way then. So we'll go 0 and 0 and 0 and 0. Okay, so let's go O's then diagonally down. So we'll go 1, 1. Let's go to 2, back to 1. And then it's X's turn. Let's go, I don't know, like 6 here off the way here. And then we'll go back to 2. And then we'll do 6 again. And then 3 now should win for O, right? A diagonal down for O wins. Game over. Awesome. So the last one we haven't tried does is if we're full. So let's try and be full. So we'll do 1 and 2, 3 and 4, 5 and 6 and 0. Right, and then we'll do 0, 1, 2, 3, 4, 5, and 6. But now I need to not make sure we're stacking these ones here, right? Because I don't want a diagonal win. So can we alternate? I don't know, 0 and 1. How about 6, 2? Oh man, this is harder to not win on purpose than I thought it would be. 4, 3, 6, 5. Okay, so we stopped them here, right? So there's no diagonal wins yet here. Okay, so X's turn, let's put it back in 1. Oops, the 1 wasn't, that's not where I wanted to go. That's all right. We'll do 0, 2, 3, 4, 5. Okay, and then we want no winners again. Let's see, so there could be a 3 in a row. Okay, no one's got a 3 in a row, right? Diagonals? Good, okay. So we'll just alternate, I guess. We'll do 0, 1, 2, 3, 4, 5, and 6. And then the last column, make sure we don't get any more winners here. Don't want anything diagonal, so let's just put the same numbers on top. So we'll do 0. Oh, no, that was wrong. I wanted that to be on top here. So, okay, that's fine. We'll go 1. Need 6 over here to stop that one. 5 looks fine. 4. Can't put an X here. Can I put an X here? 2 and 3. Okay, cool. It filled up. We didn't have. We did have a winner. Oops, that's 4 in a row. Oh well. It's close. And you can see this is kind of tedious to do it that way here. So wouldn't it be nice if we could write some unit tests to make sure this works here, right, with my Connect 4. So, excuse me. We should be able to do that, right? We should be able to test out each one of these here, given the board, as we go. Now, testing drop piece is doable, right? We can get the copy of the board. We can make sure it's the right spot. So we have lots of different things we could test if we want to get to that 100% code coverage, where we make sure that it works properly. So we should test 1 to make sure that it's full, returns a false, test to make sure out of range returns false, and test just a regular drop is true. And then we can test that my game over wins returns correctly for each one of these cases here as we start writing our tests. So to set those up, we would just call our code, right? We could just call the drop board or drop piece all the times that we need to. So I guess that might be a little tedious, maybe similar to having to type it in there. But we can do it with code and we can automate it. We can put it through loops. We got lots of fun options here on how we can do that sort of thing as we start looking at writing some tests to make sure my game behaves properly. All right, I think we're pretty good for today. Definitely a bit of review here. Hopefully some of this two-dimensional stuff was new and then playing with it, and it wasn't too bad today. And sorry I missed you in person. I should be around on Wednesday, and then I'll be running the lab on Wednesday as well as Mr. D is out of town for some conference he has to go to. It should be a lot of fun for him. What is source H? What source H file do I have here? Oh my goodness, I don't want that. No, delete that. Delete. Don't want that one. Okay, because we just added our method up here, our function up there. Okay, cool. All right, so we get this committed here. So we should see the source file connect 4. So here's vectors and arrays and connect 4. We'll commit and push that. So that's out in the class repository. If you have any questions, let me know. If not, on Wednesday, then I think we'll be able to pick up, start with inheritance, which is good. We'll have a little more time with that. So we'll get a little bit ahead, which should be good. And then our lab, we'll talk about exceptions, pointers, and vectors. And I think we should be in pretty good shape there. So then the lab the week after can be all about inheritance. Okay. So the project is coming up due as well. Don't forget the other window here. Let's see this one here. The project is coming up due. We've got September 28th. So a week from Wednesday, 11 a.m. It's going to be due. And remember, I can't take these late because I go over solutions in class, right? So it's the first thing we're going to do in class on the 28th is I'm going to go over the solution to the project. So make sure you have started this already. It doesn't have to be done yet, but get it started on it here. If you have questions or concerns, let me know. Happy to get you pointed in the right direction here. I'm not going to tell you to go away. And then we do have the exceptions and pointers quiz as well. It should be up here coming up on the 21st as well. That one's going to be due. So I'll probably be able to post the arrays and vectors quiz tonight. We'll see. Yeah, I think I can do that. Let me add myself a note. Array and vector quiz. All right, awesome. So if you have any other questions or concerns, let me know. Send me a message, find me in Discord, any way you want to get a hold of me, and we can go from there, okay? Thanks, folks. You take care, and I will see you on Wednesday then. Bye, everybody.